Still in 8.5, we are on number 4. Okay, so we are supposed to be integrating, this is lovely, over x minus 2 times x squared minus 2x plus 3. There are no combinations for positive 3 that will give you a negative 2, so that is an irreducible factor. So this is turning into 7x squared minus 13x plus 13 over this nonsense. So the first one is just a over x minus 2. But the second one, because it's quadratic, we have to put a linear above it, so bx plus c. Again, multiplying through by the common denominator. Oops, not going to fit. There we go. I get 7x squared minus 13x plus 13 is equal to, this is going to be a times x squared minus 2x plus 3, and this is going to be bx plus c times x minus 2. And then I have to multiply all that stuff out. Ax squared minus 2ax plus 3a, bx squared minus 2bx plus cx minus 2c. All right, so my x squares, this guy, this guy, this guy. 7 must equal a plus b. Okay, now let's look at the x's. And this one, and this one. Okay, so negative 13 must equal negative 2a minus 2b plus c. And then finally my constants, the ones that are not underlined, 13 must equal 3a minus 2c. Now, they don't do it in the book, but you have to solve this. You can solve it a variety of ways. There are ways even on your calculator to solve it. I'm thinking I would just use substitution. I'm going to solve this for a. A is equal to b minus 7. So my second equation is going to become, and I'm going to turn it around, negative 2 times b minus 7 minus 2b plus c equals negative 13. I put the negative 13 on the right side. And then the third equation, I'm going to have 3a, so 3 times b minus 7 minus the 2c is equal to 13. That's going to give me negative 2b plus 14 minus 2b plus c is negative 13, and 3b minus 21 minus 2c is equal to 13. And so, collecting my like terms and moving stuff around, the top equation becomes, I'm going to go over here because I'm wasting too much paper. So I'm going this way now. That's going to be negative 4b plus c equals negative 27, and then 3b minus 2c is equal to 34. So if I multiply the top equation through by a 2, and c's will cancel out, so I get negative 5b is equal to negative 20, so b is equal to 4. No, that's not right. Let me look at that again. Whoops, big mistake. A at the very top here, when I solved it, right here I'm looking, a is equal to 7 minus b. So this should be negative and this should be positive. So let me fix this. That's going to take a little bit to fix. So now I get positive 2b, negative 14. Here I get negative 3b, positive 21. Nice, what a mess. Collecting my like terms, oh, well, that actually works out better. Because the b's are going to cancel now in that first equation, so let me just stop there. It didn't want me to waste that paper, did it? Negative 14 plus c is negative 13 is all that's left of the first equation, so c is 1. And the second equation is negative 3b minus 2c equals, subtract the 21, negative 8. Is that right? I think it's negative 8. And so then I put the 1 in there, so negative 3b minus 2 equals negative 8. Negative 3b equals negative 6, so b must be 2. That's better. And then back to the beginning, a is equal to negative b plus 7, so a is equal to 5. Tangled up in the algebra. One little minus, two little minus signs. So the problem then turns into the integral of, what was a, 5 over x minus 2, plus the integral b was 2x, c was 1, over x squared minus 2x plus 3. Okay, so this first one is nice. It's 5, the natural log of x minus 2. However, the second one, if the u was x squared minus 2x plus 3, then du would be 2x minus 2 dx, and that would be amazing, but that's not what it is. So what we're going to do is we're going to rewrite it a little bit. We're going to make the numerator, change that numerator to a 2x minus 2 plus 3, because that's the same thing. And then we're going to split it. So we have our 5 natural log of x minus 2, plus we're going to make this integral 2x minus 2 over x squared minus 2x plus 3 dx, plus another integral of 3 over x squared minus 2x plus 3 dx. So we've turned this one in the middle here into a 1 over u du. So we still have our 5 natural log of x minus 2. This turns into the natural log of x squared minus 2x plus 3. And then this last guy, now this last piece is weird. I want to look at just that denominator. Move the 3 down, and we're going to complete the square. We've done this technique before. Half of 2 is 1, squared is 1. Add the 1 minus the 1. The first 3 terms factor to an x minus 1 squared. The last 2 terms are plus 2. So now this problem that looks like this is an arctan, where this is my u and my x and my u and my a. Actually, my u is x minus 1, my a is the square root of 2. So I get 5 the natural log of x minus 2 plus the natural log of x squared minus 2x plus 3, plus this is going to be the 3 in the numerator needs to come out. I need a 1 over a in front, so 3 over the square root of 2, arctan of x minus 1 u over a, and then plus the c. And the only thing I can do to clean this up would be the natural log of, and that's all going to need bars, so x minus 2 to the 5th and x squared minus 2x plus 3, close the bars, plus 3 over the square root of 2, arctan of x minus 1 over square root of 2 plus c. The only thing we didn't talk about is if the numerator is bigger than the denominator in the original problem, you have to do long division first because it's an improper fraction, and then you have that piece off in front, and then you have the partial fraction decomposition happening after it. And it is addressed in the textbook, so make sure you're looking at that. This concludes 8.5.